you're among the group of people who either are really into quantum physics or people who have used a computer, there's some big news this week. But it took place on a very small scale. Researchers at the University of New South Wales in Sydney have just created a kind of quantum logic circuit out of silicon, clearing the way for actual, we're not just talking about them anymore, we could actually build one now, quantum computers. Quantum computers are exciting because they could carry out multiple computations at once. This won't make browsing the internet any faster, but it will, for example, let drug companies test all of the possible outcomes of different chemical combinations at the same time, which could make discovering new drug treatments exponentially faster. But how would a computer like that work? Well, the fundamentals would be kind of the same as they are now. The computer or phone or tablet you're using right now renders data in binary bits. The bits are binary because they can only be in one of two states, 1 or 0. So if you have 2 bits, they can be in any of the following positions, 0, 0, 0, 1, 1, 1, or 1, 0. Those are all of the 4 combinations you can make out of 2 bits. But while each bit can be in any of those positions, they're only in one of them at a time. In a quantum computer, 2 bits could be in all 4 of those positions at once. Now, how in the name of Schrodinger's cat is that possible? Well, if you've ever heard of Dr. Schrodinger's famous thought experiment, the same logic that applies to the cat applies here. In conventional computers, bits are encoded by circuits that are either on or off, 1 or 0, by using an electrical current, which is just a flow of electrons. But quantum computers could use quantum bits, called qubits, by using a single electron. And unlike a digital circuit, an electron can be doing all sorts of things at once. A single electron, for example, might either be spinning in alignment with the nearest magnetic field or spinning perpendicular to it. But until you measure the electron, it's actually doing both at the same time. It doesn't have a defined state. This is called quantum superposition. Now, you still have to measure the spin to get a value for that qubit, so you're still going to get a 1 or a 0. But by measuring it in parallel, you can get multiple values for a single qubit at the same time. So with 2 qubits wired together, you could get 4 values, and if you have 3 qubits, you can have 8, and so on. But guess what? Making actual circuits with qubits is incredibly hard. What the New South Wales team managed to do is boil down all of these ideas to create a quantum logic gate, 2 qubits that could interact with each other. Logic gates are the basis of any digital circuit. They take data from bits, apply programmed logic to the information, and then output new data based on the result. So the team took the existing technology in a silicon microchip and reinvented its transistor, the tiny switch that turns off and on to create 1s and 0s. But instead of being controlled by a current or a flow of electrons, each transistor basically trapped a single electron and stored its spins as information. They then used microwaves and electrodes in the chip to change the spin of one electron, and therefore the information in that qubit. That information then changed the state of the qubit that it was connected to. The result was a sort of quantum if-then command, where the state of one qubit depended on the state of the other. The researchers have worked out how to scale up this design from 2 qubits to hundreds or potentially millions. And they've patented this design based on the same manufacturing methods that are used to make microchips today. So, quantum physics is weird, but quantum computing would be amazing. Thank you for watching this SciShow News, brought to you by Audible, which is giving away a free audiobook to SciShow viewers. Check out audible.com/SciShow, where you can download books like The Pleasure of Finding Things Out, the best short works of Richard P. Feynman, or practically any other book for free. Go to audible.com/SciShow to learn more.